We are all stewards of the planet, and we're called to be stewards of the planet. In all of exploration, we have three fundamental questions. Are we alone, meaning in the universe? Are there other habitable planets? And is there life elsewhere? The evidence is mounting. In the 10 seconds you're watching this amazing galactic fireworks from our Hubble Space Telescope, 3,000 new stars were formed. That's the world that I live in. The infinite possibilities is how we can get it right, most importantly, for Spaceship Earth. This is our James Webb Space Telescope, the world's greatest observatory, now unveiling where we come from. 13.4 billion years we're looking back into history to understand dark energy, dark matter. We'll get to 13.6. You might know, the universe is 14 billion years. So we're always searching. We look out to understand ourselves, to look inward. Who are we and who do we want to be? One more framing slide here. It's not an eye chart, but that very pale blue dot, that's us. Everyone you know and love and care about is right here on Spaceship Earth and all of living beings. So I love this perspective. Even in all of our exploring is why to help humanity to lift up life for all living beings here on Earth. We look at Earth continuously, monitoring the vital signs of Earth. This is a real image taken from our Discover mission. And you see Mars, my second favorite planet there, to scale. Why second favorite planet? Because Earth and Mars share a story. We're sister planets. 4.5 billion years old. Life worked out pretty well here for us on Earth. Let's not screw it up. We have to get it right. We have to be in balance with nature. But Mars probably was wet, wonderful, and wild until 3.5 billion years ago. And then something went terribly wrong. It lost its dynamo. I don't know how you're all doing this morning, but don't lose your dynamo, your electric magnetism. That's when things started to go poorly for Mars. The solar wind and radiation obliterated the atmosphere. Today I have 1% carbon dioxide atmosphere on Mars. But the MIT experiment, our MOXIE experiment, Mars Oxygen In Situ Resource Utilization experiment, living off the land. We're separating the carbon atoms from the CO2 atmosphere, recombining elemental oxygen to get O2, oxygen. You might think it's for people to live, or my spacesuits. No, first it's for fuel. The round trip to Mars with humans, we need to have our fuel depots on Mars. We have to scale it up. We can't make too much oxygen today. But first time ever, scientists, engineers, teams of artists and designers have been off-planet on Mars to do breakthrough science. I want to show you a little bit more about the spectacular science that we're doing on Mars. You might know about the helicopter, Ingenuity. How many people know about our helicopter? All right, a few, not enough. Well, we had to do breakthrough technology. We had the mission to Mars, the Mars rover. Why am I showing you? It's all about the people. But when you explore, you need to go up into the air. You go on the ground. Guess what? You go into the oceans. We always have to understand life and protect life in the oceans first. Okay, back to Mars. I'm there every morning. How's your 8 a.m. telecon? Mine is with augmented reality. 8 a.m., we get scientists all over the world. We talk to one another. I can only take 5 images, literal photographs on Mars every day, right? So you get the geologists and the scientists talking to each other. Why? Maybe you saw The Martian, right? They forgot to tell you the really important thing. We're there to find life, to find past life, to find life that might be 3.5 billion years old. Will there be life on Mars today? We don't know. We have the chemistry. We have water. We have sulfur. We have hydrogen. We have methane. So there I am with, my avatar folks. So we can all work together. And you can't convince us we're not on Mars. We are deep, deep in those 360 images. So I'll bring a little bit more of Mars to you. Here's actually always bring a microphone and a camera on an exploration mission. Here's the sound, really recent sound from Mars. It's the rover wheels. We're looking for those fossils that might have contained life. So that's the laser tapping rocks. You probably know it's always windy on Mars. Always windy on Mars. But it's not hurricane force. Kind of sounds like hurricane force. But it's just like a feather. 1% carbon dioxide, so it feels like a feather just tickling you. And here's a comparison between an ocean sonogram, and then what that would sound like in Mars. It's very soft, filters out all the noise. Same exact audiogram, but that's how it sounds like on Mars, because it's a different environment. So we're exploring, we're learning, we're trying to think about living off the land. That's how all exploration that's how all exploration succeeds. So we will become interplanetary, get humanity back to the moon next. We're to the moon to stay. We have to buy down our technologies. We can't go to Mars tomorrow, but we will get there 15 years. But now I shift gears down to Earth, because the most important work I can do every day is thinking about saving Spaceship Earth, living in balance. So welcome to the Media Lab. This is an amazing group of people. We are here to think about, to work with you, co-create the technologies of the future and experiences and the systems and networks that will really help us all reimagine, redesign our lives. Probably never been a most important time to do this. We envision, we can see a better world, but it has got to be by, with, and for all. It necessarily has to be with all of us. It has to be inclusive. Everyone belongs here in the Media Lab, but everyone belongs to all the work we do, the artists, designers, engineers, and scientists. We have 5 major themes, threads throughout this wonderful 500-person community that we have, our students, our staff, and our faculty. Future worlds is that design and action for that future we can dream of and they will want to live in. That's what I get to talk to you about today. The future is now. I'd say we're here, we're living it. What does that mean? Let me show you some of the vital signs. Again, from space, but from space on Earth. We call this eyes on Earth. I have 100 terabytes of data a day. So I have all the data I need. Now, what are we going to do with it? How do I show it? How do I curate it, show it to you so that you can take your action that you want? So we take our climate models, we take all of our Earth-observing satellites, and we study all the systems of Earth very holistically, all the systems here. So I can tell you about rain. What about groundwater? What about the clouds? What about ocean temperatures? What about changing ocean currents? And what about all the greenhouse gases? You're seeing carbon dioxide. This is emitted by humans and our natural disasters. So I want to take a little bit of a deeper dive into what I call these vital signs of Earth. Let's talk about temperature. This is the world's temperature recorded since 1880. Now, if you see blue, it's 1 to 2 degrees Celsius below a 30-year running mean from 1950 to 1980. When you see yellow and orange, that's 1 to 2 degrees Celsius above. So you can see the years here. You can raise your hand when you're born. Okay, we're into the 60s. Come on, I need some audience participation here. So there we are, the same data on the right. It's hot. 2023 just shattered all records. Matter of fact, now we're shattering each month record. August 2023 is the hottest month we've ever recorded. So I don't talk about 1.5 C, but I do talk about 2 C. What can we do? We're at 1.17 C's average day. What can we do about it? This is just scientific proof. This is just our data. Let's look at trapped greenhouse gas, carbon dioxide. I can show you methane, carbon dioxide, take your pick. I show this to you in 5, 10, 15, 20 kilometers up. Blue is less than 400 parts per million, and yellow and orange is above 400 parts per million. Today we're at 420. We don't want to be above 400. Now this isn't gloom and doom. We can do something about this. We can wake up tomorrow and absolutely change our behavior and do something like that. And it is our responsibility to live in balance with nature. I'll show you one more kind of vital signs, overall data that we're taking again daily. That's me in the South Pole. Be there again to Antarctica over December and January. Why? Because our glaciers and the melting glaciers are so important in terms of what's happening for potential sea level rise and our oceans changing and the land-ocean interface. Greenland and Antarctica hold 99% of our fresh water, trapped in the ice sheets. They're melting. We study them. This is a vector diagram. We know how the water is melting. We know how it's flowing. And then we're measuring what's the consequence. What's the consequence of sea level rise? If the entire Greenland ice sheet goes, that's 6 meters of sea level rise. Antarctica, we won't be having this discussion, 60 meters. So that's the urgency. What are we going to do about it? Let me tell you about what we're doing in some of our research here. We're laser focused on what we can all do. Everyone can act. Everyone can do something today to get our systems in balance. This is called Nroads. Hop on the web. It's an amazing, very quick, it's policy. So if you want to do something today, first we have to educate everyone. We use this with staffers, on the Hill. What about the trades, okay? We call it the dual challenge. Everyone in the world needs clean, affordable energy, and we have got to meet our climate metrics. So it's the dual challenge of energy and climate. Hop on Nroads, and you can trade. Okay, what are the transition energy sources? Nuclear, solar, wind, how much? What deforestation? You can crank up. You're in charge. You put your hands on the dials so you can learn, and then you can educate the next generation. The next generation is educated a lot of people. It's very fast computationally, but it's inaccurate given it's a global model, and it's not local. You cannot type your zip code in, okay? So that's the next step in our research. We have to give you something. What you care about is your family, your friends, your zip code. What about these vital signs? What's going to affect you when it comes to climate? And then how can you make the world a little better? So I call this satellite imagery of the future. This is where we use our machine learning, artificial intelligence. Let's see into the future. That's what we do here at the Media Lab. This is a NOAA slosh model. It's not very intuitive. You probably think, oh, red is bad in the flooding, right? If I show you this picture of your house, well, that's intuitive, but you're going to say, Dava, it's too late. I can't get out my front door. So what can we do to give you something literally in your hand that's intuitive and informative? So we take a lot of images, we use generative AI, and we serve it up to you. Here is the flood that's coming in the future, as you see in the slider here. So this is the Gulf Coast. Specifically, this is Houston. I know the next flood is coming to Houston. I just can't tell you when. So here's your infrastructure, your houses. Let's give that satellite imagery of the future, that generative imagery, to policymakers, decision makers, people on the ground. Let's get people out of harm's way. Let's talk about it for floods in this case, an example. We could talk about it for fires as well. This is where some of our transformative technology takes place. Now, this is the real story, and it's complex. And this is a complex system. So I don't ever apologize for complexity, because guess what? You're all superstars, and you have this supercomputer on your brain, and you understand this. You understand complex systems. So here's where we are in the top, just to lay it out to you, that Nroads climate policy. What policy do you want? Carbon tax, something else. You get to choose. You get to go through these simulations. And then the CO2 emissions. So we take that in, then we have global climate projections, very complex world climate projections. And I want to give you something in your hand I call the climate pocket. But to get there, I need to better understand large-scale dynamics. I need the fine scale that gets to the regional, and then I have to make it relevant to you. So far, these are the challenges. Here's where our research comes in. We're making it faster, accurate, and then more local. That's where the research is. That's the necessary integration of climate modeling, of artificial intelligence and machine learning. And I would say it also even goes to health and wellness for all. Again, that future we see that can be equitable to raise everyone up. We're optimists here, so this is what we're working on, this climate pocket. Trustworthy. Number one thing, it has to be trustworthy, right? The AI is responsible, trustworthy. We want to educate the world. I want to educate billions of people. It's all open source. Knowledge has to be free to the world, open to everyone, and then local and engaging, because again, that's what you care about. So finally, then, I want to leave you with a big idea, or maybe one or two big ideas. Here's one of my biggest. Why didn't the Earth get an embassy? I lived in Washington, D.C., and every nation got an embassy. And we forgot about Mother Earth. We forgot about our own spaceship. You're all astronauts. We're all the crew. We got to get this right. We're all here together. So we literally want to think about how can we immerse people, not just in the data, how can we act as an embassy? We need ambassadors. My hope is with my students and the next generation, call them Earth DNA, data into action, Earth DNA ambassadors. Pop up in schools, in our public schools, right here in the Media Lab, to run these simulations, show this data, and then the hardest part is get people to act just differently, maybe every day, because if we do that, then we're on it. So this Earth mission control, we can immerse you in, give you the data comes up, on your command. What do you want to see? Is it temperature, greenhouse gases, and what can I do today? My community is here. What can I do today to join my community? And we see that vision of a thriving Spaceship Earth that is for, by, and with all, and that means all living beings and all living creatures. Thank you very much for your attention.